reactions of acids with bases. Now, this we have learned from our childhood that acid plus base will give salt plus water. Now, in case you are not familiar with this, let me explain that an acid will always react with a base to give a corresponding salt, and it will give water. Let us see how. Suppose we have HCl and we have NaOH. What actually happens is that this HCl is an acid, so it gives out this H plus ion, and if it gives out this H plus ion, it also has to give out Cl minus ion. And NaOH, which is a base, it will give out OH minus ions and it will give out Na plus ions. So now what will happen, these four types of ions are present. When you make them react, these four types of ions will be present in one solution. So these H plus and this OH minus will come together and react to give H2O. And this water is nothing but the water which is formed. And this Na plus and Cl minus will give you NaCl, which is your salt. Actually, Na plus and Cl minus don't combine, they remain in ionic form, but we have equal quantities of Na plus and Cl minus, so we have NaCl in aqueous solution. Aqueous solution means the solution of water, as I told. So HCl plus NaOH will give NaCl plus H2O. Similarly, your suppose H2SO4 plus CaOH whole twice, it will give CaSO4 plus H2O, but in this case it will be 2H2O, because CaOH whole twice will release Ca2 plus ions and 2 OH minus ions, and H2SO4 will release 2 H plus ions and SO4 2 minus ions. So these 2 OH minus and 2 H plus will combine to give 2 molecules of water, and Ca and SO4 will remain like that in the solution. So if you have any confusion about this acid and base reacting, just ionize them, take out the ions, and then with the H plus and OH minus ions just form water, and the remaining which you get is your salt. As simple as that. And what are these reactions called? They are called neutralization reactions. That means an acid and base will give salt and water. Such type of reactions are called neutralization reactions. You know, when you have acidity, your stomach produces excessive acid. And this excessive acid, your stomach actually produces HCl. And this excessive acid becomes very harmful for the walls of the stomach. because this HCl will actually erode the walls. It attacks the walls of the stomach, and that is why you have that burning sensation in your stomach when you have acidity. So what you do, you take an antacid, and antacids are nothing but bases. They're just plain bases, and these bases react with HCl and neutralize it. They give salt and water. So they react with the acid, give us salt. Salt is neutral, nothing acidic, so it will not corrode attack the walls of the stomach. So it's perfectly safe. That is why after eating your antacid, this reaction occurs and you have the soothing feeling. You know, in your toothpaste also you have bases, because when acid gets when food gets stuck in your teeth, you have microbes attacking on the food and they produce acid, and to neutralize that acid you use the toothpaste, and the base inside the toothpaste will neutralize the acid. So these neutralization reactions are very important for us, very useful. Now we were only talking about acids, bases. There are substances which are not actually acids but are acidic oxides. Now these acidic oxides means that they will react with a base to give salt and water, and that means they will give the properties of the acid while reacting with the base. And when these oxides are dissolved in water, they actually give you the acid. Like you have an acidic oxide CO2. Carbon dioxide is an acidic oxide. You see, we have already seen that CO2 reacts with a base. CaOH whole twice is a base, so it will react with this base to give CaCO3, which is a salt, and water. So acidic oxides will give the properties of acid, and CO2 will react with H2O. This is not normal, but under high pressure it reacts with H2O to give H2CO3, and H2CO3 is your carbonic acid. So this H2CO3 is your acid which is present in cold drinks, soft drinks, which contain CO2. So when you release the pressure, that is when you open the tube, the pressure gets released and H2CO3 no longer remains in its acidic form, it gets converted to CO2 and H2O, and that fizzing which occurs is of CO2. So CO2 is an acidic oxide.